We need to learn about permutations and combinations before we get into our probability, so then we can do all kinds of neat things. So we got some new terms here. Our first one before we talk about our permutations and combinations is factorial. Okay, factorial, we use the exclamation point symbol in math for this. And formally it means the product of the positive integers less than or equal to the number. Yeah, it's pretty confusing. Let's just look at it. So let's say I wanted 4 factorial. What that means is I'm going to take 4 and I'm going to multiply every number less than that. Every integer that's less than or equal to. So I start with 4 and I take it times 3, times 2, times 1. And I would get 24. So if I want to do like 8 factorial, which 8 with an exclamation point, that's how we read that, 8 factorial. I'd start with 8 and I'd go 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And I'd multiply them all together. And there's actually a factorial button on your calculator. The ones that we use, if you click the button that says P, R, B for probability, it brings up a little menu and you'll see the exclamation point over there. You'll just have to scroll over to get the line underneath it and then hit enter. So you'd have to type in your number first and then hit that factorial in order to do it. And we'll talk about that tomorrow. Okay, for permutations and combinations, the only difference between the two is permutation, objects are arranged so that the order is important. So order matters for permutation. Whereas for a combination, it's not important. Order does not matter for a combination. And we'll explain why here. So a permutation might be, let's say it's like you're looking for the finishers of a race or something. Right? They have places. There's like first place and second place and third place. Okay, they're all different. Order matters when it comes to a race or for political office. Right? President, vice president, secretary, they're all different places in political terms, things like that. So when order matters, permutation. Combination when it's not important. So that means, let's say I was just gonna like pick 5 guys for a team, and I'm choosing out of like 100 people. It doesn't matter what order I pick them. I'm just picking 5 people. So like picking teams or picking something for an event or things like that, when order is not important. So we're going to bring in a couple variables here. We're going to use n, and that's going to stand for the objects taken. And we're going to use the variable r at a time. That's probably confusing. Once we see an example, it'll make sense. So for a permutation, what we do is we take n factorial, and we divide by the n minus r factorial. Okay, and we'll see that in a second here. And the combination works the same way. The only difference is it's n factorial over n minus r factorial. But we multiply by the r factorial as well when we divide there. So n objects taken r at a time. Kind of confusing. Let's look at an example. So first thing we need to do is decide if it's a permutation or combination. So it says Dennis has a 4-digit passcode to access his email account. The code is made up of the even digits 2468. Each digit can be used only once. How many different passcodes could Dennis have? So does order matter? Like, is the number 2468 different than the number 24648? Yes, it is. So order matters. So that means we're going to use permutation. So write the word perm here. So that means I'm using the formula n over n minus r, n factorial of n minus r factorial. So I got to look at the n. N is the number of objects. Well, it's a 4-digit passcode. So n, there's 4. And how many numbers do I have to choose from? Well, I also have 4. So that's what the r is. We're taking 4 at a time. That's what that r means. Okay, so n is like the total. R is the how many you're choosing from. Well, in this case, they're the same. So I'm going to go ahead and plug those in. So really, I'm taking 4 factorial over 4 minus 4 factorial. Well, I have 4 factorial, which is 4 times 3 times 2 times 1, over 0 factorial, which is actually, in math, we just use 1. So it's really just 4 times 3 times 2 times 1, which gives us 24. Okay? And the other way to look at this is, and this is the way I do it a lot of times, I think of, well, I have a 4-digit passcode. I have 4 numbers to choose from right away. Well, once I pick one number, now I only have 3 to choose from. Now I only have 2 to choose from. Now I only have 1 to choose from. And we multiply. That's the other way to do permutations, right? Think about how many things that you're choosing, and then how many do you have to choose from for each one. Okay, so either way will work there. How about this one? A group of 40 seniors, 5 juniors, and 7 sophomores have volunteered to be a fundraising committee. Mr. Davidson needs to choose 12 students out of the group. How many ways can the 12 students be chosen? So does order matter? Does like the senior coming first differ from the senior coming second or third? I don't think so. Order does not matter, so we're going to use a combination. So now I'm taking n factorial over n minus r factorial times r factorial. And we have, what would my n be? How many total students? We got 4, 5, and 7 for a total of 16. And he's choosing how many? Looks like 12 students. So that means my r is 12. So I could just use my formula and take 16 factorial over 16 minus 12 factorial times 12 factorial. Well, that's 16 minus 12 factorial is really 4 factorial. So I'll replace that. And if I expand, let me start writing this out a little bit. Watch this 12 factorial. I bet I can get rid of it. 16 times 15 times 14 times 13 times, well, still 12 in the rest, so I could really write the rest of it as 12 factorial. And then we have 4 factorial times 12 factorial down here. What would we notice about our 12 factorials? They're gone. They cancel each other because it's really 12 times 11 times 10 on the top and bottom, so they would cancel each other. So then what's really left on the bottom there? Let me just get rid of that. Get rid of that. So really we have the 4 factorial, so 4 times 3 times 2 times 1. And I'd go through the math and do that. So 16 times 15 times 14. And then I divide by that 4 times 3 times 2 times 1. And we end up with 1,820. So the combination, I couldn't do it this simple way like I did it. Remember how I did it for the permutation? I had the 4 spots and I was choosing from 4, so I was able to count it down. Doesn't work as nice and neat for a combination, so I actually have to go through my formula there. There is a different way you could do it, but we're not going to look at that. Okay, you might also see it in your book like this. It's saying, for number 1, like the permutation, you have 7 to choose from, taking 2 at a time. So that's how it works. They put n and then the r part of it. So you could just use your formula. So I have 7 factorial over 7 minus 2 factorial. And let's just look at that one quick. So I go 7 factorial or 5 factorial. And if you think about it, it's really 7 times 6 times 5 factorial, which will cancel. So just 7 times 6, which gives you 42. Okay, so you could have done that. Or if I would have thought about it with the permutation, it's much easier, right? I can do that simple way that we did right at the beginning. That first problem. You have 7 to choose from, and you're only picking 2 spots. So you have 7 to choose from for the first one. Well, after you use one, you only have 6 to choose from. So 7 times 6 is 42. So the permutation is nice and easy. So I can do that down here. You got 3 spots. 1, 2, 3. 9 to choose from, then 8, and then 7. Bang, bang, bang. There we go. So it's really 72 times 7. That goes a lot quicker, right? 504. Where the combination, so here's my n, here's my r. So it's really 6 factorial over, subtract them, so 6 minus 4 factorial times the r factorial. I just did the shortcut there. And if we go through it, so you could just work out all the math. Although I'm going to rewrite this top so the 4 factorials cancel. That's 6 times 5 times 4 factorial. And those guys would cancel, so it's really 6 times 5 divided by 2 times 1. And we end up with 15. Okay, so I'm jumping some shortcuts here, but you can go through and go ahead and go through all the math if you're having trouble with the shortcuts. And I'll try to help you with those shortcuts tomorrow. Okay, last couple here. We'll try to fly through these. Word processing program requires the user to enter a 5-digit registration code made up of the digits 1, 2, 3, 4, 5, 6, and 7. No digit can be used more than once. How many different registration codes are possible? Okay, so you only have a 5-digit code with these numbers, and they can't be used more than once. So does order matter? Yes, order matters. So this is a permutation. So now we're thinking, well, I can do it the easy way. I can go 5 digits. I got a 5-digit code. I have 7 to choose from for the first one, and then I only have 6, and then 5, and then 4, and then 3 to choose from. Let's see what I get here. If I multiply those, 7 times 6 times 5 times 4 times 3. I get 2,520. Let's check the actual formula and see what we get. The n would be, well, we have 7 digits to choose from, and we're only choosing 5 of them. So I'd have 7, so n factorial over n minus r factorial, which is really 2 factorial. Well, and if I think about that, if I wrote it out, it's really 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1. I could have wrote the 2 factorial. Well, those two cancel with those two, and we get the exact same thing, right? 2,520. So permutations are a little bit easier than those combinations, aren't they? And the last one, if I look here, got some coins in a bag. If we're pulling 4 coins out of the bag, does it matter what order? If I pull out like a penny, and then a nickel, and then a dime, is that different than a dime, and then a nickel, and a penny, No, the same thing, right? Order does not matter, so this is a combination. And we were saying, how many total coins do we got? 22. And we're pulling 4 out at a time. So there's our formula. So remember, n factorial over n minus r factorial times r factorial. So we have 22 factorial over, well, I subtracted 18 factorial times, well, 4 factorial. That's our r. And if I think about this, let's expand out my 22 times 21 times 20 times 19. I'm going to stop at 18 and write my factorial because that'll cancel. Bang, bang. And then I go through the math and take 22 times 21 times 20 times 19 divided by 4 factorial. Remember, the nice part is we can actually do that on our calculator, and we get 7,315. And there we go. So the biggest thing is deciding, is it a permutation or combination? You can either go through your formula, or if it's a permutation, you can kind of go through the shortcut way.